Good day. My name is Rati Priyadashini and I am from class 5 Topaz. Today I am going to present about rusting of iron and metal corrosion. History or past research about rusting of iron. Brown suggested that the first stage in the rusting of iron is production under the influence of carbonic acid of ferrous carbonate, which is subsequently converted by atmospheric oxygen in presence of moisture into ferric hydroxide or rust. History or past research about corrosion of metal. Louis Jacques Stannard is the person who discovered electrochemistry, hydrometallurgy, and corrosion science. What is rusting? Rusting of iron is a redox reaction where oxygen acts as an oxidizing agent while iron acts as a reducing agent. Rusting of iron occurs with the presence of water and oxygen. What is metal corrosion? Corrosion of metal is a redox reaction where the metal is oxidized spontaneously when the metal atoms release electrons to form metal ions. Differences between rusting of iron and metal. Rusting of iron is a redox reaction where oxygen acts as an oxidizing agent while iron acts as a reducing agent. While corrosion of metal is a redox reaction where the metal is oxidized spontaneously when the metal's atom release electrons to form metal ions. Rusting of iron occurs on metals such as iron and steel, while metal corrosion occurs on both metals and non-metals. Rusting is a type of corrosion while corrosion includes rusting. Rusting of iron occurs with the presence of water and oxygen. However, metal corrosion occurs with the exposure of air or chemicals on surface. Rusting of iron does not require any chemicals. However, metal corrosion requires corrosive chemicals. Rusting of iron forms rust which is red-orange in color. However, the compound or layer formed by corrosion can be different colors such as blue, green, and so on. Rusting of iron produces a series of iron oxide. However, metal corrosion results in salt or oxides of metal. Describe the mechanism for rusting from the aspects of oxidation and reduction. The surface of iron in the middle of water droplet where the concentration of oxygen is low serves as the anode negative terminal. Iron atom loses electrons and undergoes oxidation to form iron 2 ions. Electrons flow through the ion to the end of the water droplet where the concentration of oxygen is higher. The iron surface at the part becomes the cathode positive terminal where reduction occurs. Oxygen that dissolves in water accepts electrons and undergoes reduction to form hydroxide ion. Iron 2 ion is green but rust is brown because iron 2 hydroxide undergoes continuous oxidation with oxygen to form hydrated iron 3 oxide. Rust is brittle, permeable and does not stick strongly. So, water and oxygen can permeate into the iron metal underneath. Iron will continuously rust. Rusting of iron occurs faster with the presence of acid or salt because when these substances dissolve in water, the solution becomes a better electrolyte. Electrolyte increases the electrical conductivity of water. Iron in steel form is widely used in building materials. For example, it is used in the manufacturing of vehicles. Rusting of iron would cause the structure of iron to become weaker. Every year, a huge financial provision is required to overcome the problem of rusting of iron. How can metals that are more electropositive than iron prevent rusting of iron? State examples of application in daily life for each situation. Sacrificial protection is a corrosion protection method in which a more electrochemically active metal is electrically attached to a less active metal. The highly active metal donates electrons to replace those which may have been lost during oxidation of the protected metal. How can metals that are more electropositive than iron prevent rusting of iron? This is because the more electropositive metal can lose its electrons more readily than the less electropositive metal. So, when iron is in contact with a more electropositive metal, rusting of iron is prevented or inhibited. For example, magnesium is more electropositive than iron. Process of sacrificial protection. In this method, iron is attached to a more electropositive metal which acts as a sacrificial metal. It is used for objects that are exposed to conditions that speed up rusting, such as water and seawater. For example, bridge pillars and hulls of ships are usually attached to zinc blocks, while underground pipelines are tied to bags of magnesium. Being more electropositive, the sacrificial metal would act as the anode, whereby it is oxidized, protecting iron from rusting. So, sacrificial metal is also known as sacrificial anode. Sacrificial metal has to be renewed from time to time. Sacrificial protection is used for corrosion protection in underground tanks, water heater, above ground tanks, hulls of ship, and pipelines. Advantages of sacrificial protection include low cost, provides protection without power requirement, does not require maintenance, and simple installation and operation. Disadvantages include periodic replacement of the anode, increased noise level from the anode, current output cannot be regulated, periodic replacement costs, especially in ships, since they must be dry docked. Examples of application in daily life for each situation. Zinc plates on ship hulls. To protect the hulls, the shipbuilders put pieces of zinc on these hulls. They are made of metals more reactive than material used for the ship's body and system. As such, they shield the ship's body and system while the ship stays protected, giving rise to the name sacrificial anodes. Underground pipes. Pieces of zinc or magnesium alloy are attached to pump bodies and pipes. The protected metal becomes the cathode and does not corrode. The anode corrodes, thereby providing the desired sacrificial protection. These items are known as sacrificial anodes and attract the corrosion to them rather than the iron or steel. The sacrificial anodes must be replaced periodically as they corrode. The iron pipe will be connected to a more reactive metal such as magnesium through copper wires. The magnesium will donate its electrons to the iron, preventing it from rusting. Iron, which is oxidizes, will immediately be reduced back to iron. Steel pillars. Magnesium preferentially oxidizes to form magnesium ion. The electrons produced can flow along the steel cable and give the ore rig a small negative charge. This makes it difficult for iron in the structure oxidize and form positively charged ions, as this would add even more electrons to what is an already negatively charged structure, and the steel rig remains intact. In time, the block of magnesium is eaten away and has to be replaced. This is much easier and cheaper than carrying out repairs on the structure of the rig. Thank you.